Alright guys, we're going to take a look at some practice problems right now for you to look at before we do the real problems. So if you look, I have two different circuits here right now. The top one up here is a series circuit. The bottom one down here is a parallel circuit down here. So we're going to take a look at doing the solutions for these. So what I'm going to do is I'm going to start out with the series circuit first here. We're going to go ahead and work on that one. So let's talk about, remember we have Ohm's law involved here. So Ohm's law is just V equals IR, or the quick, easy way to write this out. Let's draw the triangle with the T inside of it. This is V at the top. We have I right here, and R is my resistance, right? So at any time, if I cover up the V, then it just says I got to do I times R. If I cover up the R, it says I got to do V divided by I, and so forth on down the line. All right, so that's my Ohm's law that I have. I also need to remember some certain properties about these things, right? So this is a series circuit. So in a series circuit, all the voltages add up to make the total voltage, right? That's all part of KVL, Kirchhoff's voltage law. We know that the current stays the same. So whatever the current is right here is also here, here, and here. It stays the same throughout the whole circuit. And then we also know that all the resistances add up to make a total resistance. All right, so those are the pieces that we need to know for solving this problem. So I'm going to go ahead and label this out right now. This is my V sub T equals 125 volts. I need to calculate R sub T and find out what that is. I need to calculate I sub T, that's my total current in the system. Now I'm going to go ahead and label this one here as resistor 1, resistor 2, and this one is resistor 3. So 50 ohms, 30 ohms, and 20 ohms. So then at this location, I have a current at resistor 1 that I need to find. I have a current at resistor 2 that I need to find. And I have a current at resistor 3. I also have a voltage at resistor 1, I have a voltage at resistor 2, and a voltage at resistor 3. So those are the pieces that I need to solve right now. So I'm going to start out with, first and foremost, is I want to find out what my resistance total is. And remember, the resistance total is simply the sum of the resistors. So it's going to be resistor 1 plus resistor 2 plus resistor 3. So what is resistor 1? It is 50, and the way I drew it. And resistor 2 is 30, and resistor 3 is 20. When I add these together, I find out that my resistance total is 100 ohms. Okay, so that's this guy right here, 100 ohms. That's a beautiful ohm symbol. And I'm going to go ahead and circle it to show that I got it finished. All right, next on the line then is I want to find my current at this point right here. Because once I find my current, remember the current stays the same through the whole series, I'll know all three of these answers really fast. So what's the rule for current? So according to Ohm's law, if I cover current, it means it's just voltage divided by resistance, right? So I'm going to go ahead and say my current total is equal to my voltage total divided by my resistance total. So I'm going to have 125 volts divided by 100 ohms. And that's going to yield an answer in amps. So 125 divided by 100 ends up being 1.25 amps. Right, so that's how many amps that I have. I wouldn't need to put it in milliamps. That would be, what, 1250 milliamps, but there's no use in doing that. So amps is perfectly fine. It's kind of, if you're talking about 125 volts, you're probably talking about some kind of household electricity, and they tend to talk in amps anyway versus milliamps. All right, so there's my total is 125 or 1.25 amps. So I'm going to list that right here, and I'm going to go ahead and circle that guy because I got it finished. So we know that all the resistances have to be 1.25 amps because that is how it works in a series circuit. 1.25 amps. And then right here is 1.25 amps. So there we go. I've got all my amps solved. All I have left now is to check my voltages, or to find my voltages, and then I'm going to do a check at the very end using KVL. So remember, again, same deal. I'm trying to find voltage, right? And I know my resistance and I know my amperage and my current. So if I hide the voltage symbol right here, it's just I times R. So for VR1, it's just going to be I R1 times R1. So what is IR1? We said it's 1.25 amps, and R1 is 50 ohms. So when I multiply those together, I'm going to get a voltage of 62.5 volts. So this guy right here is 62.5 volts. He's been solved. Next, I'm going to do my voltage at resistor 2. Same process. It's I at resistor 2 times the value of resistor 2. So my I is 1.25 amps. My resistor 2 is 30 ohms. Okay. When I multiply those together, I'm going to get a voltage of 37.5 volts. So there it is. My voltage there is 37.5. Guess I should have spaced this out a little bit more for you, and that's in volts. So now I got to do my voltage at resistor 3. And that is my current at resistor 3 times my value of my resistor 3. So my current at resistor 3 is 1.25 amps again. My resistance is 20 ohms. So when I multiply those together, I'm going to get 25 volts. So this guy right here equals 25 volts. So the last thing I want to do right now is I want to do a check. So I'm going to use, if you remember, KVL. Kirchhoff's voltage law says in a series circuit, all the voltage drops sum up to make the total voltage, right? So I know my total voltage is 125. So if I take my three voltages, 62.5 volts plus 37.5 volts plus 25 volts. Those are my three voltage drops that I have here at the resistors. If I add those three together, they do indeed turn out to be 125 volts, which matches my voltage total up there. So that is how that guy is actually completed. That's a series circuit. So now what I want to do is I want to move on to a parallel circuit. So let's take a look at our parallel circuit. Again, same deal. I'm going to put the Ohm's law triangle up here. So V, I, and R. Okay. We need to know some stuff about parallel circuits. In a parallel circuit, I know that the voltage stays the same across the whole system. But the current is different at each location, and they must add up to make that. Or not that, I'm sorry, the total current. And then last but not least, the resistors don't add up. You have to do the reciprocal of the sum of the reciprocals to get the resistance total. Right? So that's a little bit different on us there. So right now I have my voltage total equals 125. I'm going to need to calculate my total current. I'm going to need to calculate my total resistance in there. I'm going to call this guy resistor 1, resistor 2, and resistor 3. So there's my three resistances. And at this location, I'm going to have a current at resistor 1. And I'm going to have a voltage at resistor 1. I'm going to have a current at resistor 2 and a voltage at resistor 2. And I'm going to have a current at resistor 3, and I'm going to have a voltage at resistor 3. All right, right off the bat, easiest thing to do, I know that the current or the voltage stays the same all the way through the whole system. So this guy is 125 volts. Solved. This one's equal to 125 volts. Solved. And this one equals 125 volts. Solved. Okay? Next, I want to calculate my individual currents. This is where I go with it, but you don't have to do it this way. I like to calculate my individual currents now at this point because these guys are super easy to do, right? So I know if I want to find current, if I hide the I, I'm left with voltage over resistance, right? So if I want to calculate the current at resistor 1, it's going to be the voltage at resistor 1 divided by resistor 1. So my voltage is 125 volts. Sorry about that. My resistance is 20 ohms. Right? When I do that and I divide that out, I'm going to find out that my current at resistor 1 is 6.25 amps. not milliamps or anything else, just straight up amps. So there we go. This guy that was resistor 1 here, 20, right? So this is 6.25 amps. Sorry, it's kind of blending in there. So now I want to calculate my current at resistor 2. Again, that's the voltage at resistor 2 divided by resistor 2. So 125 volts, right, divided by 100. Okay, what does that equal? 1.25 amps. So there you go. This guy's at position 2 is equal to 1.25 amps. There we go. We got that guy solved. I'm going to do my current at resistor 3 equals my voltage at resistor 3 divided by my resistor 3's value. Okay? So we got 125 volts divided by 50. So in that case then, when we do the division, we're going to end up finding out that it's 2.5 amps. So that means this one is 2.5 amps. I guess if I'm staying consistent, I should probably put it as 2.50 amps. All right, so that one's been solved. Now we have a couple different ways. I can now, remember KCL says all the currents have to add up, so I can add these 3 currents up and get that one. Or I can solve for this one and then solve for that one and then check it with KCL. So we'll go ahead and do the check method right now. So what I'm going to do is I want to calculate my resistance total, right? So my resistance total is the reciprocal of the sum of the reciprocals. So 1 over R1 plus 1 over R2 plus 1 over R3, right? So it's the reciprocal of the sum of the reciprocals. So I'm going to have 1 over 20 plus 1 over 100 plus 1 over 50. All right, so this is important when you're entering, if you're going to do this in the calculator, if you want to punch it in your calculator, if you type in 1 and then do divided, you got to make sure you put this whole thing in parentheses or you're going to mess up your answer on this. Or you can simply do 1 divided by 20 plus 1 divided by 100, 1 divided by 50. Take that answer and you probably have an inverse button of 1 over x on your calculator. Hit that and it'll do the reciprocal for you. Right? So when you do this, you end up finding out that your total resistance is equal to 12.5 ohms. Okay? 12.5 ohms. So there we go. 12.5. This guy has been solved. So now if I want to calculate my current, right, I want to find current. So I take the Ohm's law, hide the current. It's just V divided by R. So I'm going to say current total is equal to my voltage total divided by my resistance total. Well, what is my voltage total? It's 125 volts. What's my resistance total, or my total resistance is 12.5 ohms. Okay, so I'm going to divide those two. So 125 divided by 12.5 is going to yield 10 amps for my answer. So I'm going to go ahead and say that equals 10 amps up here. And last but not least, I want to use KCL to check it, right? So KCL says if I add up all my currents, okay, so I'm going to take IR1 plus IR2 plus IR3, and I'm going to see if they equal the 10 amps up there, right? So IR1 we said was 6.25 amps. IR2 is 1.25 amps. And IR3 is 2.5 amps, right? 6.25 and 1.25 equals 7.5. 7.5 plus 2.5 equals 10 amps. And it checks out, right? So KCL is correct. And we've now fully solved out this parallel circuit. All right, I hope that I hope you guys find that helpful, okay? So now you can utilize this to help you in solving some of the problems that you're going to encounter now. All right, you guys have a great one.